Atomic packing factors. Okay, so what is atomic packing factors? Let's define that. Atomic packing factor is also known as packing efficiency or density of facing. So it indicates how closely atoms are packed in a unit cell. How closely atoms are packed in a unit cell. It is defined as the ratio of the volume of atoms per unit cell to the total volume occupied by the unit cell. Atomic APF, atomic packing factor, ratio of what? Volume of atoms per unit cell over volume of the unit cell. Right? Therefore, let's call this volume of atoms per unit cell. Let's give it lower V, and volume of atom of the unit cell, upper V, uppercase V. Volume of atoms per unit cell and volume of the unit cell. Now, mind you, the volume of atom is what? Is fair, right? And we know that the volume of a sphere is 4/3 pi radius cube. So, volume of atoms per unit cell is what? 4/3 pi radius cube. Or we can also define the APF as number of atoms in unit cell multiplied by volume of atom, volume of an atom, divided by volume of the unit cell. Okay, that's that. Number of atoms times volume of an atom divided by volume of the unit cell. How closely atoms are packed in a unit cell gives you what? Your atomic packing factor. So let's look at the atomic packing factor of the face-centered cubic structure, the body-centered cubic structure, and the FCC and the HCP cubic structure. Let's start with BCC lattice. APF for BCC lattice. Now, number of atoms in a unit cell for BCC. Okay, let's do that. Let number per unit cell for a BCC structure, okay, for a BCC lattice, the number of atoms per unit cell is equal to 2. How did we get that? Recall that for a BCC structure, body-centered structure, we had what? A cube, right? For the unit cell, we had a cube where the atoms are at the corners or the edges. And one in the middle, right? And one in the middle of the unit cell. So if we form a space lattice with our unit cell, we will only see that Each of these atoms has what? 8 neighbors. 8 neighbors. That is, it will only contribute to that unit cell. It will only contribute 1/8 times the 8 neighbors which it has plus the 1 at the middle. So the number of atoms for a unit cell of a BCC lattice would be what? 1/8 times 8 plus 1 if I construct a space lattice. So I have what? 1/8 times 8 plus 1. So the number of atoms becomes what? This 1 plus 1, which is what? 2. 8 atoms at the corners plus what? 1 in the middle. And each of these has what? 8 neighbors. 8 neighbors. So its contribution, one of this atom, its contribution would be what? 1/8 times the total neighbors, 8, plus what? The 1 at the middle, which gives us what? 2. So the number of atoms per unit cell for a BCC lattice is 2. Next up, we have what? Volume of an atom. Volume of an atom. Volume of an atom. Volume of an atom, let's call that small v, right? V equal, I said an atom is what? Spherical in shape. It's spherical in shape, right? Therefore, the volume for a sphere is 4/3 pi radius cube. And finally, volume of the unit cell. Volume of unit cell. V is equal to A cube. Now recall that our lattice constant, but A, in relationship for a BCC structure, for a BCC lattice, the lattice constant A in relationship with the radius is gotten to be 4r√3/3. Mind you, we derived this, right? And we got that A in relationship with R is what? 4r√3/3. So let's impute all this to get our atomic packing factor for a BCC lattice. Therefore, our APF equal, imputing that I have what? Number of atoms in a unit cell, which is what? 2 for a BCC, multiplied by volume of an atom, 4/3 pi radius cube, divided by volume of unit cell, which becomes what? Okay, yes. Volume of unit cell, which is A cube, which now becomes what? Our A is what? 4r/3 all cube. Right? Okay, let's simplify. We then have that this gives me what? 8/3 pi radius cube divided by 4 raised to power 3 gives us 64 bracket 64. Okay, let's solve that separately. This gives me what? Okay, 4r√3/3 cube, right? This gives me what? 64 r cube 3√3, all divided by 27, 1 and 3, right? 64 Okay, so our final answer for this gives me what? 64 root cube root 3 divided by 3. APF equal, okay, let's simplify. 8 over 3 pi radius cube divided by 64 root cube root 3 over 3. And this gives me 8 over 3 pi radius cube multiplied by 3 over 64 root cube root 3. Let's cancel out. These cancels out, right? These cancels out. And I have that my APF 8 pi over 64 root 3. Therefore, APF equal, this goes here, 1. Okay. After simplifying, multiplying, you have that this gives us 0.64, which is the same thing as 64%. Therefore, the atomic packing factor of a BCC lattice is 0.64 or 64%. This gives you how close the atoms of a BCC structure is.